Good morning, friends. My name is Shivam Srivastav, and we are here to study fractions topic. Fraction is a topic for basic mathematics and starts from primary school. And we will learn today why do we need fractions in day-to-day life. What was so urgent that a whole topic and a branch of math was developed called fractions. We'll also study why fractions were required, how fractions can be represented, how we can operate on fractions. So let's do one more thing. Fractions, and so this is fractions, and then we have why do we need fractions first of all, and how do we represent fraction, that will be the second part, and third will be how to operate on fractions. So let's begin one by one. Why why because we needed to represent a fraction, a part of something. Say this is a cake, and we want to distribute it to three people, A, B, and C. But this is one piece of whole cake. How will we do it? So we will just cut it into three parts or break it into three parts. It's one part. So A gets this much part, C gets this much part, and the remaining gets B this much part. So why fractions were required? Because we were doing it in practical life. It is easy to break and split a cake, but it's very like you have to have develop a separate mathematics or logic how we can represent them. So how we can represent them? We can represent them in number form. Number form. How? So above example, each part, there were three parts. First of all, to understand it more clearly, there were three parts. There were three parts, and each part was one third. One third. So we can say it was 1 by 3, or we can represent it as 1/3 or 1/3. This is the way we can represent. This is a simple form of representing it. And we can take this graphical example over here. This is the whole circle over here. And now we have this. Split it into three parts. A gets this one, B gets this part, C gets this part. So this is a cake that was split into three parts, whether equally or not equally, that's altogether different thing. And how we represent this thing? We represent this thing as in here 1 by 3. So this is the way we represent it. Now the question arises, why do we need, or like what we will do after this thing, when we have learned that this is going to be the why reason that we needed to represent this into a numerical form, that is 1 by third. Now how to represent it, we have already known it. Now how to operate, or like why should we need it? What was the need to have this fraction thing when everything was going good? No. So as humanity progressed, and there were a lot of calculations going on, and calculations required, you can say, operations. And in basic mathematics you would have done addition, you have minus things, that's a subtraction, then you have divided things, and you have multiplied things. So these are the basic three operations, four options that you have been doing with number system. For instance, you have 1 plus 1, which gives you 2. This is addition. If you have 1 minus 1, it gives you 0. And if you have 1 multiplied by 1, it gives you 1. And if you have 1 divided by 1, it gives you 1. So here, basic thing is that these operations are taking on whole numbers, or we can say integers. And when it comes to fraction, how will we do it, how are we going to do the operations of basic operations, that addition, subtraction, division, multiplications. We will learn this in the next step or the next slide. Let me wipe it out for you. In the end, when we have done with the whiteboard presentation, I have prepared a PowerPoint for all of us to see and go one by one with what all have been discussed over here, so that you have a better understanding and a recall of all we discussed in this class. So let's take representation as the first thing. I want to represent a fraction, and I have a cake over here. It is a cake. Now I use a dot and I say that I want to split it into five parts for five persons. That will be like A, B, and then say C, then D, and E. So how will I do it? I will just basically going to split it into five parts. So I'll say one part goes to E, the other goes to A, B, and this one goes to C. So this part will be going to E, this will be going to A, this will be going to B, C, and D. This is a cake and it has been split into five parts. Five parts. And each one part will be a part of this whole. So fraction and the whole part, that's five. So it will be can be represented as each part can be represented as 1 by 5 of it. Mhm. So this is the representation of a cake. Now if I have say a watermelon, and it's say like this is the watermelon over here, and I want to distribute it among two boys, A and B. So I what will do, I'll just split it into half, and this half I will give to A, the remaining will I give to B. So out of the whole one part I gave, that is one part to A. So how many parts were there after splitting? Two parts. So it will come in the denominator, and the how many parts I gave to A will be in the numerator. So to understand this thing in comparison also I can like to, yeah, here A received one part out of the whole five parts. So what we got to know that in the bottom we write total parts, and over here we write number of parts received by a particular person. Say for instance over here everybody received one part, so it will be 1. And how many parts you split the cake? 5. So 5. Same over here, how many parts you split the watermelon into? 2. And how many parts did A got? 1. So this is the same thing. Now to understand it, for you can say a real life example that could be related by everyone, say for example we can consider a pizza over here. So let me wipe the whole part for whole whiteboard for you. We have a pizza, and this pizza is going to be distributed among four friends. There are four friends, and this pizza has to be distributed among four friends. Now if A, B, C, and D are the parts of the four friends, like A receives this A part, B receives the B part, C receives the C part, and D receives the C part, D part. So it will be like each one of them got one fourth, one fourth of the pizza can be represented as one fourth. Same will be happening for B, C, and D. Now if if just to like understand a one step more, C did not wanted to have his part, and he gave his part to D. So 1 by 4 part of C and 1 by 4 of D. So now how many parts D had total? That is a question now. So in the beginning I told you why do we how do we operate? So this way we have to add the C's part plus D's part of pizza. This will give the total part of total pizza by D. So there we see that we need to do operate on the fractions and use the addition over here. So we will see in the next steps how we do the addition also. So I'm just like explaining you the reason why have we had the whole branch of fraction over here. Now before that, we'll first understand the fraction itself, the representation of fraction in mathematics. What is the top part called, the bottom part called, what are the types of fraction, how are the fractions being classified. This is a very important thing because this will clear a lot of doubts. So first of all, we'll see classification of fractions. So first fractions we can say, first part we'll start with example, and this example will be 2 upon 5, which we can say 2 fifth also. So in words it could be written as 2 fifth. In mathematical form it could be 2 by 5. If we were to see the first part, that is the bottom part and the top part. So this is the top part and this is the bottom part, or the in the down side of the. So the bottom part or in the down we have denominator. Now D and D. So this is a clever way to remember how we can say that it is going to be the denominator because it comes in the down part. The top part will be the numerator. So numerator is always on top. We can represent it in n by d also. N is the numerator and d is the denominator. So the denominator will be d and numerator will be n. This is the way we will represent a fraction, or we can say we had the breakup of understanding what fraction is. Now I was talking about the example of fraction. So we had 2 upon 5. This is the numerator. This is the denominator. Then there will be another example I'll put forward to you before we understand the classification exam. Say 3 upon 2. And then another example 1 3 upon 5. Here we see there is a numerator and there is a denominator. And this extra thing has been coming over here now in the picture. So 2 is the numerator and 5 is the denominator in the example number 1. And we see that the number 2 is less than number 5. So we can say numerator is less than denominator. When we meet this condition, the fraction is called proper fraction because it's proper. Proper in the sense that the numerator is smaller than the denominator. It's in perfect form. We do not need to disturb it. It's in a stable form. While if we have the second example, that is the second example, the 3, that is the numerator, is greater than the denominator, that is going to be 2. So what we see that numerator is greater than denominator, a condition which is the reverse of the previous condition. The condition has been reversed. So we call this fraction as just the opposite, because the condition has changed reverse. So we, the proper opposite of proper will be improper. So we have improper fraction. Now we come to the third part. Numerator is there, yes. Denominator is there, yes. Numerator is less than denominator, yes. But wait a minute, we have something extra. What is this extra part called as? It's the whole part, the whole part of the fraction. So it's called something different now, because we have this thing called as proper fraction. This is called improper fraction. Now what you should call, it's not an improper fraction because the numerator is less than denominator, but we have a whole part. So it's mixed. It's a mixed match now. There's a fraction also, there's a whole number also. So we will have it as mixed fraction. We call it mixed fraction. Now the thing that we have to observe over here is that there is some correlation or relationship with the improper fraction and the mixed fraction. They both are interrelated. This one is interrelated to this one, and we will see it in the next step. What is the relationship between them? And after that, we will take an example of proper fraction, improper fraction, and mixed fraction. Then we'll move to the other parts of classification of fraction, like fraction, unlike fraction, and equivalent fraction. So let's do it. Let's start with this thing called. Let's divide the whole page into two parts. Here with the improper fraction, improper, and we have the mixed fraction. So step first of all, example will be like 3, where the numerator is greater than the denominator, that is 2, and over here we just added 3 upon 5. This is an example we take away. So if we want to convert, because these are convertible, I mean to say this fraction, improper fraction, can be converted into mixed fraction and vice versa. So let's do one thing. Let's write this example down and wipe it off. If we want to convert this thing into an equivalent mixed fraction, what we will do? We will divide the numerator by the denominator. So, and we will get a quotient, and we will get a remainder, and below will be the divisor. Divisor, of course, will be the denominator itself, always. And this way we will convert this improper fraction into a mixed fraction. How? Let's see. We do it for you for sake of simplicity. We have the number 3 as the numerator here. 2 will be dividing 3, it goes into 1 time. We have 2 written over here, we subtract it, we have 1. So 1 will be remainder represented by R. 1 over here will be the quotient represented by again Q. And this is the divisor, again, which was the denominator only itself. So what we get over here, quotient will be 1, remainder will be 1, and divisor will be 2. This is the way to convert a improper fraction to a mixed fraction. Now we'll have another example also for clear understanding. This was one of the most, you can say, simple example. Say we have a number called 4, and we have a denominator, say 3. Of course, the conditions are met for being an improper fraction, where numerator is greater than denominator. Proceeding to the step, we will divide the number 4, that is the numerator, by 3, and we see it goes one time. We have 1 left over here. This will be the remainder, this will be the quotient, and this will be the divisor or the denominator. So the equivalent will be 1 whole part, 1 remainder, and 1 the result will be 3. So we can say the mixed fraction equivalent of improper fraction 4 by 3 is 1 by 3. Now the same process can be reversed because these are interchangeable. So if we want to go back from a mixed fraction back to an improper fraction, we just have to simply multiply this and add this one. So how we'll do? Let's see. You multiply this. So what we multiply? We are multiplying the divisor by the quotient and adding the remainder, that is the r over here. This is the remainder, this is the divisor, and this is the quotient to get the equivalent of mixed fraction. So 1 into 3 plus 1 will be 3 plus 1 will be 4 according to the rule of bracket of division, multiplication, addition, and subtraction. So we have 4 over here. So this will be the numerator. So we get the numerator. Denominator will always be the same, 3 as it was over here, as it is going to be over here. So we get 4 upon 3. This is the way of converting a mixed fraction back to an improper fraction. Now moving forward, we'll see how to understand the classification of like fraction, unlike fraction. We have over here like fraction, where, and we have here unlike fraction. Unlike fraction. So what are the conditions? Like fraction means denominator is going to be same. Is same, and over here denominator d is not same. So to understand, we have a couple of fractions, say 1 upon 2, and then we have, okay, sorry, this will not work over here. If we have say 1 upon 5, we have 2 upon 5, we have 3 upon 5, we have 4 upon 5, we have 4 upon 5. So where we see this denominator, this denominator, this denominator, and this, all 4 are same. So it is going to be, all these 4 fractions are like fractions. Even if we compare the two, these are like fractions. If we have the third one, it's also a like fraction. For all, why? Because denominator is same. Now in the previous example, I was taking 1 by 2. If we have 1 by 2, we have 1 by 3, we have 1 by 4, we have 1 by 5. But these are unlike fractions. Why? Because denominator is not same. And there's a thing to be observed, friends. Even though the denominator is not same and same, that is the only way we are doing it. This is the basis of classification. We can observe the numerator over here are different, but that does not affect the condition of being a like fraction. A like fraction is totally governed by the denominator. Similarly, unlike fraction is not governed by its numerator at all, because numerator is same over here, but denominator are varying. So what we find, that denominator is the key in fraction, in subject fraction, and you will get to know it at later stage while you will learning operations on fraction. So let's go to the example parts and the graphical representation of those examples. And I will just sum it up in next 5 minutes. We have studied the proper fraction over here. Then we had improper fraction. Then we had like fraction. Then we had unlike fraction. And of course, we forgot the mixed fraction. So we have the mixed fraction over here. And we have the like, unlike. These are the fractions that we studied so far. Now, what we see over here, the condition that numerator is less than denominator, while over here numerator is greater than denominator. Over here, there's a whole part besides numerator and denominator, and the denominator are these are same. So when we talk about like fraction, they should be more than one fraction. Only then, because more than one fraction can be compared. One fraction itself cannot be called a like fraction or unlike fraction. Same ways for unlike fraction. If you compare two fractions and you find that they are like or unlike, you have to have more than one fraction to compare. This one is a proper fraction. Then, for if we have an improper fraction, we convert it to a mixed fraction, and vice versa. We can convert them to improper fraction as well. So you got to know that these are the types of fractions. Then, before entering into the operations of matrix of fraction, sorry, we have another keyword, that is equivalent fraction. Now, what does equivalent means? Equivalent means similar. Like if you go to a shop and they ask you to produce an ID, but you don't have the ID, you show it on your mobile. It's a called soft copy. Soft copy is basically an equivalent of your original ID card. Likewise over here. So if I have a fraction called 1 by 2 and I want to make it change it to a different part, say I multiplied by a factor of 2 on both numerator and denominator, we get 2 upon 4. So this will be an equivalent fraction of 1 by 2. They both are related. So I can say this is going to be equivalent to 1 by 2. These operations or this concept helps in addition, subtraction, multiplication, division initially, and then at later stage, even higher mathematics, it helps us a lot in solving mathematical problems. That's all I would say from my end for this basic coverage of fraction, basic topic for primary mathematics students. I hope you would have enjoyed the session. And now we will be moving on to the slide section in a while. Let me wipe the board for you.